Engineering information is a valuable asset. Engineering information can save lives, accelerate revenue, and protect your license to operate while reducing your capital expenditure and operating costs. How do we generate high-quality engineering information during complex and large capital projects? When thousands of engineers, contractors, and suppliers are collaborating, and work is going on 24/7 in multiple locations around the world. Thursday, 8 a.m., The Arena.
Ladies and gentlemen, please welcome Mirko Stock, Intergraph Process Power and Marine Senior Vice President, Solutions and Strategic Alliances.
Good morning, everybody. I hope you're having an excellent conference so far. So today what we're going to do is we're going to talk a little bit about brownfield assets, so plants that have been in operation since many, many years. So when you own one of those, you're actually facing many challenges. One of the challenges that you face is actually that an operating plant must adhere to numerous laws, regulations, standards, and policies. And these 4 business processes that you see there on the right-hand side, just a couple of examples for processes that are required to do this. The processes that you see there, they all have one thing in common. All of them require access to high-quality, consistent, and complete engineering information. And that engineering information can actually take different forms. It can be in the form of documents, it can be in the form of data, it can be in the form of models, 2D drawings, and so on and so forth. So having all of that information available at any given point in time for all of the people who have to execute these work processes here on the right-hand side is very important, and it actually requires a central information management approach. Unfortunately, reality is a little bit different. Reality is a little bit more like that the majority of, not the majority, but a lot of information in many plants around the world actually is unstructured, or in some cases even paper. So that is not exactly what you need to carry out these business processes and all the other business processes that play a role in an operating facility. But first of all, so what do we mean by unstructured information? So we're basically talking about unintelligent formats, like scanned documents, PDFs, images, just log documents. Documents that are being duplicated and scattered all around the organization in unofficial storage devices, like, for instance, personal computers of employees and so on and so forth. We're talking about information that is created, shared, and stored without having proper governance processes in place. And we're talking, as I said before, we're talking about information that in some cases still exists in the form of paper. So bottom line, unstructured information is not a good basis to operate a complex and very often hazardous plants. So how big is that challenge? All right, we have a couple of owner-operators here in the room today. I'm sure if I would ask the question, do you have a major challenge with unstructured information? Please raise your hands. I'm pretty sure that the number of hands would be very low because people really don't have that problem in this room. So let's just assume for today, nobody in this room has that problem. So let's talk about, well, what about the owner-operators who are not in the room today? And so what we did in order to assess that, we asked Tech Validate to kind of conduct a little anonymous survey around 200 professionals in the owner-operator community. And here's what they told us. So pretty much half of the group said that 40% or more of the information in their existing operating facilities is unstructured. Okay. Again, half said they spend more than 20% of their time searching and finding information. That's a significant amount of money just to kind of find information. And then we have 60% who say, well, we're not really completely confident that in case of an emergency, we would be able to kind of find the appropriate information. So that is scary. Now, they also gave us some quotes. Right? I'm just kind of look at 2 or 3 here. Like, a lot of critical information is not centrally stored. When you need information, you have to ask around to find the right person. Okay. So I was a project engineering manager for an S&P 500 chemicals company. Or we had the most trouble with having so many new people who do not know how to find information. Okay, right. And then an information manager, again in a global engineering company, says organizing collected data from scattered places has been difficult. Yep. It's difficult, but it's unfortunately required. So what we want to do today is we want to talk about what can we do in order to solve that problem or help solving that problem. And I'm not going to do that alone, and I would like to kind of welcome on stage Brad Broughton from Intergraph, Fahim Khan from HxGN Systems, and Mark Carell from Accenture. Hey, Brad. Good to see you. Fahim, good to see you. Hey, Mark. All right. So, and we're going to talk about that in the context of a real project that we did together basically a couple of weeks ago. That was the project that Dani Odendahl was referring to in the video interview that we did on Monday evening in the keynote. So we have been working with basically 3 of us, Intergraph, Leica, Accenture, together with Eskom, on Matimba. Matimba is the world's largest dry-cooled power plant. And before we kind of walk through the process and tell you what it is that we did there, let's look at the achievement. So basically, I'm going to show you a little video that is, illustrating what we achieved after that, 2-week project. What you will see in this video 2 weeks before was documentation and paper sitting in different places, not structured, not integrated, not linked, no nothing. It was just a massive amount of documentation. So let's have a look at how that looks. Right. So this is a photorealistic laser scan, and what you see here are hotspots that have been created by Leica Geosystems geotagging capability. You can now basically click on that laser scan, which is a photorealistic representation on the plan, and you navigate, for instance, in this particular case here, to P&ID or other associated documents. That P&ID was formerly on paper and on PDF, not intelligent. Now it's intelligent after it ran through Fusion, and you can now use that intelligent P&ID to navigate to other information sources, such as in this particular case, for instance, open a valve list. Okay? So now when we go back to the laser scan, let's just show what has been established by Fusion really. So you can click on this component here, and you will now see down here, it's a little bit difficult to read, but you will now see all of the relationships and links that have automatically been created by Fusion to all of the other information, and you can even print that out as a tag report. You can now say, okay, so for that particular component on which we just clicked, what is the associated information, what are the associated documents, what other tags, and so on and so forth. So I think that is relatively impressive. I hope you would agree with that. And I would now like to talk about, well, how we did that. And when we talk about how we did that, we're not only talking about like the functional way of doing it. Like, this is not only about technology. When we talk about how we get there, there's a couple of things. How can we do that in a cost-effective way? How can we do it so that it starts adding real business value for you guys immediately and incrementally, and you don't have to go through a massive project that takes months before you see some first benefit, right? How can you do it so it's scalable, so that you can do it on a small plant or on a very large plant? And how can you do it so that it becomes repeatable, easily repeatable? So really what we're talking about here is how can we do it, almost like on an industrial scale. And that, of course, is very dependent upon the methodology that is used in order to do this. And for that, I would like to now hand over to Mark from Accenture. Mark.
Thank you, Mirko.
Sure.
And good morning, everyone. So I'm going to provide you a high-level view of the approach that we followed for this project. I think what's important to understand is this approach is based on very skilled people that have been certified. There's tools behind that, an industrialized process, okay? So that makes the approach very predictable and very reliable. We use for running this approach our delivery center in Accenture, and we use two of them. One in South Africa and the other one in India. As you can see from the slide behind me, the high-level approach is split in two streams. The bottom streams cover everything which is related to 3D scanning and the production of the true views. And the top stream is all about document analysis and processing. And now I'm going to cover that part. I'm going to cover the top stream. But before I go through the detail of that stream, I just want to explain a little bit the sheer load of volume that you have, all those files coming to you. It's mind-boggling, I would say. Okay? So in a brownfield scenario, you have a lot of them. And many of those files are not interrelated. You don't even know the quality of those files, to be honest. And there are thousands and thousands and thousands of them. So what we want to do during this analysis and document processing stream is really to look at all those files, try to connect and focus essentially on the files that are relevant for the client, that bring the best value, and make them searchable so that we can find tags, so that we can use them efficiently during the maintenance and operation process. Okay? So let's get started. And we start, obviously, with one of the very important activities called scope and planning. So as mentioned to you in the scope and planning, what is the focus you need to have in the work you're going to be doing here is that you need to sit down with your client and figure out what are the main equipments, the most important equipments that you want to scan. Those are the ones that are generating the most cost in terms of engineering management, maintenance, and operation. So here, you see, you can have different approaches, Pareto, ABC, and so forth. I mean, think about the 20-80% rule. And here, we'll be looking at the 20% of equipment that are costing 70% in a yearly base on operation and maintenance costs. Those are the equipment that you need to focus. And obviously, we're going to focus on the document that related to those equipments. Okay? It's important that we focus on this because the plant itself keeps evolving a lot. And the client, your client, will want to have results very quickly. So that's the reason why of this focus. All right, so let's move to the next step. And the next step is that once you have the scope agreed on, then you start analyzing the document that you received. And again, you have a whole lot of document. So the approach that we use in this analyze phase is really a two-step approach. Okay? And I make a caricature here. I make it like very simple and short and everything. I want to give you a high level of this. But that's basically how it works. So two steps. First step, it's important is that you get all your data, and the first thing is that you need to do, you need to concentrate again on the files which are valuable and relevant for the scope defined previously. Okay? So again, those are the files that are associated with the 20% of the critical part of the asset. And here we use directory structure and file types. You go through it. So you may find, thanks to the naming of the directory, all the files that are necessary. You can look also at file names, obviously. And you can look at the file types. I'll give you some examples. There's some files that I would not consider. For example, a Word document that would be related to the legal contract of the project. Probably not very interesting for the 3D scanning activity we're going to do. All right? Other presentation, like PowerPoint presentation for the board of directors, and get rid of these files. You don't need that. Okay? So that's the first step. And then you start narrowing the number of files. The second step now, we look at the structure of the files and their tagging to ensure that it will be processed optimally in the next step. So you understand, I mean, this is a very labor-intensive work. Okay? And all these filtering activities completed by our Accenture Delivery Center. They're very good at it. They can do that very fast and at a very cost-effective way. Okay? Now, once the document has been filtered, we move to the document processing. And here we're using a scanning and OCR engine, optical character recognition engine. It's called ABI. But to be honest, you could be using any other engine for this work. Okay? And so what we're going to be doing is that we're going to be working on different types of documents. And there are really three types. Here I show you two, but I'm going to show you the third one. First type is the native files. Second type is the Microsoft Office files. And the third type is the image files. So here you see the native files and the Microsoft Office files. And most of the time, they're fast-tracked to the fusion process, because limited manual activity needs to be done on those files. Okay? And by the way, there are very good readers that can automate the process of reading them, extracting tags and everything as part of the system already, as part of Fusion. So you can send those files directly to be ready for the Fusion process. Now, the third stream is related to the image. And the images are more complex because they require more intensive labor. Okay? They come in various shapes, various formats, and they're sometimes provided just as a paper. So you need to scan them. Okay? So I want to detail a little bit what's happening on the image, and you're going to understand exactly what are the different steps that we need to go through and how we need to use ABI. Okay? So here you see a screenshot of the ABI interface OCR engine. And before fusion processing takes place on image file, there are really 4 steps required. And we're going to go through each of them. The first step is the setup. And during the setup, the team will create specific tag patterns, okay, into the ABI engine so that you can scan the files and then you can identify those different tags. So this is really lexical rules. And as you can see here, any combinations of letters and numbers will be used to match the patterns to extract the tag or identify the tag within the file. So when you have defined all those rules, you can go to the next step. And the next step is the document processing itself. So it's really a batch processing approach here. Okay? And what you do is that you send all your files to the ABI engine. They're going to scan using the patterns that you have entered in the setup phase, and they're going to detect the different tags related to the files. Now, this is what's going to happen. ABI is a smart engine, and it's going to give you a confidence level on the scanning of the file. And you can see here that you enter a next phase, which is called the verification phase. As you can see here, there's a set of files that went through the process. The ones that are in green, they're ready to go. You send them to the fusion process. The ones that are red, this is a message coming from ABI that said the confidence level is not good enough. And then you need to look at those files. And there could be 2 issues. Number 1 issue, the document is really not readable. And then you need to have a visual intervention to look at it and try to find tags. Second approach, there are tags in it. The document can be read. But hey, you forgot to set up the patterns in the setup phase. So what you need to do is that you need to look at this, create the rule, put that back in the setup phase, and do that again. So you understand it's a very iterative process here. Okay? Now, once you've done all this, you go to the last phase, and the last phase is the export phase. So the final state is to export the files, which generated the readable PDF, okay? And also the XML that contains important meta tags related to the document. So those meta tags could be the version of the document, could be the description of the document, the revision, and obviously the tags, okay? So this XML document is processed by Fusion to load all the OCR process document, okay? Now I'm going to hand over to Mirko for the next explanation of the approach.
Great. Thank you, Mark.
You're welcome.
Okay. So I think that was a great summary, how to attack and address all of these documentation that exists already. Now, there's still many plants that don't benefit from laser scanning. And that is, of course, in the process of kind of taking a lot of momentum, is in the process of changing significantly. And I just want to, kind of go through what additional value laser scanning and photorealistic representations actually can add to that process. And I would like to ask Fahim to kind of quickly take through that, please.
Thank you, Mirko. Thanks. Thank you, Mirko. Good morning, everyone, and welcome once again. What I have is the privilege to share with you our perspectives on the technology of high-definition surveying, or HDS, and to specifically look at 3 elements. To look at the business drivers, the business benefits that our customers are enjoying. To look at the technology components that constitutes and comes together to deliver this value of HDS. But then to look at the work process, the nuts and bolts the phases that are required to get the projects done. So let's maybe start with the question of why. Let's look at the business drivers behind HDS. Today, we operate in a constantly changing, dynamic environment with an ever-increasing amount of unstructured information. And as you heard in my colleague's presentation, Smart Plant Fusion is perfectly placed to handle this unstructured information. But the desire to connect this unstructured information with the reality that's out there, the real-world information, is truly where HDS shines. With this availability of high-definition 3D information, we see our users take advantage of the capabilities that the technology offers to do more with this information. For instance, site inspections, site walkdowns can be executed more effectively simply through the availability of this user-friendly, high-definition 3D photorealistic information. And this information is also available throughout the enterprise. This information could also be describing assets and facilities in remote locations. We see customers, for instance, operating in Korea, scanning facilities in Algeria, really bringing bringing all of this virtual information in one place and serving this information throughout the enterprise. With the information that's now available in the enterprise, we see new users connect to that data. And as these new users connect to that data, they find new applications, they solve new problems, they carry out training, they carry out new activities with that information. And the benefit of HDS is all you really have to do is to capture that information once. The data that's captured once can be reused for different applications. For instance, in the case of Smart Plant Fusion, the projects can be commissioned for this activity, but that information can be reused for isometric production, can be reused for space planning, constructability analysis, volumetric analysis, and so on. The possibilities are quite unlimited, and it's quite exciting. And what is most interesting is today you can carry out these entire activities with smaller teams, fewer resources, and really get these paybacks, if you like, on the investment that you make in HDS at a much shorter time frame. So it's quite interesting as to what technology delivers to us today. Now that we've looked at some of the business drivers, I'd just like to jump into the technology components that come together to deliver the value of HDS. Our view on HDS is that the technology is a combination of 3D surveying, 3D scanning, 360-degree imaging, data management, information extraction, and a delivery solution from Leica Geosystems. And these solutions are designed to be integrated. They're designed to be serving the industrial requirements that we face in the market. They're designed to work in hot, cold, difficult, dusty environment. And they're also designed to work with industrial-grade software solutions that scale based on the size of the projects you have and are not restricted with computing power. And I'll touch a little bit more on this later on. So we've looked at some of the business benefits. We've looked at what the technology of HDS really means. Let's maybe look at the project phases that are involved to execute an HDS project. It really comes down to 3 phases: the data capture phase, analysis phase, and an integration phase. Today, HDS information can be captured with a single push of a button. This single push of a button gives you accurate, complete 3D information, survey data, photo information, all inside one database. But as you know, one setup is not enough to execute projects, to complete the sites and the facilities that we have. We typically capture hundreds, if not thousands, of scan positions. And the work process after that is to come back to the office to try and build a relationship between these scans, to merge them into one coherent database. This activity is semi-automated. It requires some time and is traditionally one of the many bottlenecks in executing projects. What we have done to remove these bottlenecks recently is to introduce a complete automation in the registration and the merging process. So today the relationships between scans can be analyzed automatically. You can literally come back to the office, tell the software to analyze, and the merging process takes place automatically. So that's quite interesting. That again cuts down some of the project execution time. So now we have captured high-definition information. We have merged these scans together. The next step is to build a linkage between the digital world and the real world. And this linkage is created through the concept of geotags. You can think of geotags as spatial bookmarks. These spatial bookmarks are created once, and again, in our software technology, we analyze the relationship of the geotag within the scan. So you only have to tag once, but they get populated throughout the entire database. And it's quite efficient. So once you've had these geotags created, the next step is to produce true views, and these true views are ingested into Smart Plant Fusion automatically. So that work process that I've just described is highly, highly automated today. It's very efficient, and you can really execute these projects with one system, one person, and maybe from a project metrics perspective, the number that you can take away is it is a reasonable expectation to see 60 to 80 scans captured per day on site. Of course, this depends on the shift time that is allowed, the site conditions, but that's the efficiency that we're looking at today. So this integrated solution really delivers the true value of HDS. It's beyond just the measurement of points. It's beyond just data capture. And with this, I'd like to pass to my colleague.
Great.
Thank you.
Thank you, Fahim.
Thanks.
Okay. Well, actually, I could have stayed there. So now we have basically the two input sources together. We have right, everything from a document perspective has been analyzed, has been pre-processed, OCR'd, etc. We now have our photorealistic true views, and now it's time to have a look at what Fusion does with all that, and that I would like Brad to summarize.
Thank you, Mirko. Okay, so let's talk a little bit about the role that Fusion played in this project, and also how it can help you migrate from an unstructured, unmanaged, disorganized world of legacy documents to a more managed environment. But it's really important to note that you can do this incrementally. You can do it step by step over time. This is not a big bang approach. We've made it very easy for you to take these steps incrementally. And we like to talk about this migration as taking place in 5 different steps. The first is the rapid capture of documents. As Mark told you, they were prepared and gave focus to the area that we wanted to focus on. So pulling those into Fusion rapidly into the structures that we provide. The next step is the identification of masters. Typically, you find some documents that have many, many different duplicates and copies and revisions, all with the same document number. So it's important to identify which one best represents the current configuration of the plant. The next step is link and cross-reference. So this is where Fusion starts to examine the contents of each file, since we've now identified the masters, and it starts creating those links and cross-references. Of course, identifying the best master out of the group doesn't necessarily mean that all of the information in that document is accurate and correct. So in this step, QA and QC is where we actually apply some engineering judgment to make sure that the documents are correct, before then transferring control into a managed structured environment. So Smart Plant Fusion covers the first steps in this process, and then we have ability for you to uplift that information into SPO, and Mirko will tell you a little bit later about how that is done. So let's talk about each of these first 3 steps in a little bit more detail. The first is the rapid capture of information. First, you teach Fusion where to look for documents, the various drives and folders that have been prepared in the previous analysis that Mark talked about, so that we can pull them into Fusion. Fusion then can repeatedly poll these locations. People, of course, are creating new documents and copies, so even after the step where you may have identified the master, if a new document appears, we'll pull that in and make it evident that you need to go through that step again. Fusion then analyzes these documents and organizes them into a single structured environment based on user-defined roles that you set up as part of the project. All of these files are linked back to their originals. We don't change the original files or where they were found. We're just pulling them into Fusion for this organization step. Fusion then uses this information it discovers from the file name and folder structures to begin creating these links and cross-references that make it very easy for you to navigate the documentation. Now, as we've said, when you're looking through many different directories and folder structures and file structures, you always find multiple copies and revisions of the same document. So before we proceed to the next step, we have to examine the content of the files. It's important that we identify the best masters. And the good news is the Fusion helps you do this quickly and efficiently. Now, this step, I want to make it clear, this doesn't happen automatically. This is where you have to apply some engineering judgment, but we give you the tools to make it very quick. Sometimes a quick review of just the thumbnails will make it very obvious that certain files are outdated or old, and you can quickly eliminate them from consideration. But next, an engineer can do a more detailed side-by-side comparison. And I'll show you what this looks like in the tool in just a moment. This is a specialized workbench that lets you do overlays and zero in on the parts of each file that are different from the other. Now, to determine which document actually best reflects the current plant configuration, this is where the laser scanning comes in. So you can use a 3D model if it's one that's current, or you can do a laser scan, which really allows you to do sort of a virtual walk down. You're looking at the current scan and the document side by side, and you can make that rapid comparison. Now, using these tools, engineers can quickly and effectively identify the best master version of each document. So let's take a quick look at how this looks in Fusion. First, the engineer can see from this quick review of the thumbnails which files are outdated and simply marks them as outdated, and off it goes. Next, you look at the side-by-side comparison, or you can do an overlay view. When you do the overlay, it zeroes in and highlights the area that's different. I want to make this clear that this technique can be used to compare different file types, which makes this very, very powerful. So in this case, we're looking at a PDF compared to a native file on the left, and using this slider to show which area of the drawing is different. So once these masters have been identified, the last step in Fusion is to examine the contents of that master file and begin extracting intelligence so that we can build those links and cross-references. This helps Fusion create this single point of access to all of your engineering information very, very quickly. So if you remember the survey that Mirko talked about earlier, he said that the majority of the respondents admitted to spending 20% or more of their total time just finding and validating information on documentation. Some in the survey spent as much as 80% of their time. Well, 20% of your time is one day out of every week. Imagine getting a majority of that time back. So with Fusion, now that all this has been captured and organized and linked and cross-referenced, it makes it very easy to find the information related to a given asset, which saves you time, frustration, and probably the worst thing of all, it keeps you from depending on the wrong information to make your decisions. Back to you, Mirko.
Thank you so much, Brad. Very good. All right. So let me summarize what we have seen so far. This is what we started with, right? I mean, different silos of information and documentation, sitting in different areas all over the place, not integrated, not linked. And basically, in many cases, a big question mark in situations where you want to find validated information. And this is where we got now. Information is still not perfect everywhere, right? Because you still might have some, some outdated stuff in there. But it is definitely much better than what you had before. It is now integrated and linked, and it is accessible in one place. And the value associated with that, as Brad already mentioned, is very significant, right? Because what you have done is you now have dramatically reduced the time required for the folks to find information. Quality of the information has improved. So the question is, well, where do we go from there? Is that it, or can we now add more value to it? The good news is we can, and Brad mentioned that already, that we are in the process of adding a capability to promote information from Fusion into SPO. And I'm now going to show you a video. It's a very simple video, and we're going to take a very simple example just to make sure everybody here in the room really understands the concept. So basically what we will do is we'll take a document that exists in Fusion, and we will transfer that over to SPO. So let's have a look at that. So here we are actually, this is Fusion Link. That is how that capability is called. And we are now going to look for, for a list of tags, and then we're going to pick the one, for a list of documents, then we're going to pick the one that we actually want to transfer. And we will say, okay, validate. And now what Fusion Link will tell us is, well, I can't transfer that thing, because in order for that document to exist in SPO, it needs to have, that classification information here. It needs to have a system and so on and so forth. So we now go into SPO, select from the relevant information and structure information over there, assign it to that document, thereby enriching the value and completing the metadata information associated with that document. And then that document can go across to SPO and is now available in SPO. So what does that mean, being available in SPO? First of all, what it means in SPO is now you're now sitting in the, in a complete change-controlled information management environment, both from a data perspective as well as from a document perspective. So that is good news. And there's more good news, because you can now use that engineering information to underpin many different business processes. Just a couple of examples here, we can't manage all of them. You can now use that information to perform inspections. You can use it for logout, tagout purposes. You can use it to kind of, support modifications. So you can now kind of leverage that, you can leverage that data that now has a high quality, that is change managed and change controlled, that is now accessible. You can leverage for all of these things. Just want to give you a little quick example, talking about inspection. Some of these work processes, of course, require mobile support. We have a mobile inspection assistant in SPO, and that is what I'm going to show you here right now. So here we are on the mobile device. We are opening the briefcase, in which we have all of the information that we need for our inspection rundown. You see that all of the documents that were available in SPO can be available on the, this is like the valve list that we saw before, can be available on the mobile device here as well. And we can, of course, now benefiting from the laser scans that we have done, we can use that to actually help inspection people or maintenance people to find the devices. They go out with that thing into the plant, say, show me where the device is, and it goes exactly, zooms on. And then by clicking, same capabilities as you saw before, by clicking on that, you can access either, like relevant information, or in this particular case here, kind of inspection check sheets. You can add the information that you need to add, the findings during the inspection run, add it here, and then later on, when you go back to the home office, that information synchronizes back into the SPO database. So you all of a sudden have added a lot of value by, first of all, accelerating the inspection run. It's much easier now for folks to kind of find, the appropriate things. They have all of the information that they need with them, manuals, etc. They can document stuff immediately there, and it goes back into a change-controlled environment. And that was just one little example, right? And of course, there's many, many other business processes in SPO that add a lot of value that I'm sure you're aware of. Okay, so I very much hope that you like the story and value proposition that we have discussed here so far. Before we call it a day, I would actually like Brad, Fahim, and Mark to come back and quickly re-summarize like the key value propositions on their side, and also maybe give a little bit of an outlook, where we might be going in the future from here. With that, Brad?
Thanks, Mirko.
Yep.
Well, as Mirko said, it's all about producing real business value. We all know that everything these days has to be justified from a business perspective. So how does Fusion deliver these results? First, it helps you rapidly capture information wherever it happens to exist in your network. It also then helps you determine the best masters very quickly and efficiently, which eliminates the risk of relying on the wrong information. It extracts intelligence and creates these links and cross-references, which helps you locate what you need by what you know. It then provides this very intuitive portal, which is further enhanced if you have a laser scan, but that helps you find all of your documents very quickly and efficiently. The single point of truth the single point of access cuts down on the time and frustration that can be caused by having to search for information in multiple places. This also dramatically improves the timeliness and the accuracy of the decisions that are made out in the field because people have access, ready access to the right information. Now, being able to reduce the number of walkdowns, as I said, doing those virtual walkdowns, helps reduce time spent in plant and all of the risks associated with that. And in an emergency response situation, Fusion can give you quick access to those correct documents. And finally, and this is the good news, Fusion deploys very quickly, in a matter of weeks, which helps you show results very, very quickly. Fahim?
Thank you. Thank you, Brad. I think as you've heard in the discussions earlier, HDS is quite an important part of the Fusion process. It's an important part of the process, but it's not a compulsory step in the process. It's a value-added step in that process. And what our customers can expect from Leica Geosystems in this solution offering is some of these following elements. They can expect a complete open system philosophy. The system is not just designed to work with Leica Geosystems sensors. They're optimized with Leica Geosystems sensors, but they will work with all major sensors that are available in the industry today. And this data that's supported from the sensors can also be reused in all major software products. So it's a full interoperable solution when it comes to the integration with Fusion. The second element that our customers can expect from us is a fully integrated system offering. It's integrated from data capture, from data analysis, from data integration, and this integrated process, it delivers efficiency, delivers better ROI for you in your projects. What you can also expect is industrial performance. No matter how hot, how cold, how dusty, how difficult, these systems are designed to work in the projects that you need them to work. And perhaps what is most important is the products and technologies that we offer are provided through a worldwide network of professional service providers. We've been in this business for over a decade, and in this period we have a network of very professional services offerings that can be delivered through our customers, no matter where you are. And that worldwide reach and scalability is as important, and the technology today is really proven, integrated, and available. And I would like to say that the journey absolutely continues. As I said, the scanning technology is not new. It's something that's been around for actually over 13 years. But we're quite proud to say that we are the innovation leaders in this space. It was over 5 years ago that we came up with something called TrueView, a very compact web-based point cloud format that can be used as it's used in Fusion. We were the ones that came out with geotags, a very efficient way to link the real world with the digital world. And what I'd like to do is to give you a sneak preview of what is to come from a technology standpoint. If you look at this video, this is a short clip of the experience that you can expect from our new point cloud delivery platform. This is where we take the point cloud to the cloud. This is not a data set that's sitting on a computer drive, on a file. This is something that we can stream over the internet to you no matter where you are. And if you're familiar with point cloud data sets, they could be in the terabytes of size in the day's data capture work. These huge files, just simply copying them from one place to another place takes time. But we have this optimized delivery technology that allows us to stream this information to you no matter where you are, no matter what platform or device that you're working on. This video that you see is actually rendering the point cloud. Typically, this takes quite a few hours to produce. But here what we see is a real-time rendering experience. And that's, again, what you can expect from point cloud technology. Gaming-like experience, photorealistic experience that you've come accustomed to with TrueView, but now this is in a 3D environment. So this opens up new opportunities, new paradigms, new use cases on point cloud technology. We certainly are very excited with what is to come, and we will continue to drive this innovation. And with this, I'd like to pass to my colleague to share his perspectives.
Thanks, Fahim. My slide came up a little bit earlier, but I believe that by now you understand the Accenture contribution in this entire process. We are doing analysis and document processing, not only for capital projects, but we've been doing that for 20 years. You know, in many industries, we're serving 5 industries in the world. And for example, in industry like finance and insurance, we've been doing document management, and we get like data factories, and our delivery centers are very good at it. So now you understand that in this context, Accenture plays a very important role. And I want to go back to what Mirko said initially. What we're looking for is we're looking for something which is professional, which is industrial, and our people are very good at it. We have 50 delivery centers across the globe, supporting clients in 150 countries in 39 languages. I think what it means for a client also is very simple, is that for our clients, it's important to have 35 people to do this work. And we're investing massively to train those people, to get them skilled in ABI, in Fusions, in Intergraph. Okay? That's very important for us. The second thing is that we're investing massively also is to make sure that basically they do that again and again, and they repeat basically the work. So the approach they use is, as I said, reliable and predictable. Now, Mirko mentioned also that it was very important to scale up and scale down teams and be able to cater for how big the volumes you're going to have to process. Our team are dedicated to do these things. So you can scale them up, scale them down at will. It's very simple. The second thing, which is very important, is that because we have 50 more delivery centers, I mean, those people can work in different shifts across time zone, using a follow the sun approach, you know, across time zone. And I think I would say the last one again, I mean, is this industrialized approach that we have put together. I guess with this, I'd like to hand over to Marco.
Great. Thank you, Mark.
You're welcome.
Okay, so don't leave. I hope you like that. I would like to ask you to please be back tomorrow morning at 8. Tomorrow morning at 8, we won't have Intergraph or partners on stage, but we actually have, well, a little bit of Intergraph, but I mean primarily, you know, our clients on stage. So we will have E&I and ConocoPhillips. E&I, you know, you learned that in the keynote, already recently implemented Smart Plant Cloud. And we have ConocoPhillips in Norway, which is probably one of the largest SPO implementations that we have in the world. They're going to talk about their experiences, the value that they got out of that. So it would be great if you know, we have a nice party tonight. Don't party too much, and please be back tomorrow morning at 8 a.m. And with that, have a great rest of the conference. And go to the zone. Thank you.